Alright, so in this video I'm reviewing the problems assigned on Friday, September 6th in preparation for your upcoming quiz on Monday, September 9th. Alright, so on this review, there's 5 questions on adding and subtracting polynomials, and the rest are all multiplying. Now, this is going to be very similar to what you're going to see on the quiz. Alright, so if you're able to do this, no problem, then you should do great. But otherwise, I will be going through all of these examples, right, just to make sure you all understand. All right, so we'll start with the first section, right, adding and subtracting. All right, so like I said, the quiz is only going to be on adding, subtracting, and multiplying polynomials. All right, so fairly straightforward stuff. All right, so starting with the first one, notice that I have a polynomial in parentheses minus another polynomial in parentheses. This minus right here is going to go to each term on the inside of the parentheses, right? You're subtracting the entire second polynomial from the first one. What I like to do and what makes this easier for me is to just rewrite the entire second polynomial, just changing the sign of everything. So minus 5x cubed minus 12x squared plus 10. Right? I saw in class today there was a very common mistake. If you're subtracting everything, you have to change the sign of every term inside the parentheses. So this minus 10 is going to become a plus 10. Right? And because we didn't do anything to the first polynomial, I'm just going to rewrite it. Right? So just like this. And then from here we can combine like terms. Right? Notice I have 2 terms with an x cubed. Right? 16x cubed minus 5x cubed. When you're combining like terms, you just subtract or add the coefficients, and then you leave the exponents the same, right? So 16 minus 5 is going to get you 11x cubed. Let me write in a darker color. 11x cubed. All right, and then 9x squared minus 12x squared are more like terms, right? So we just combine the coefficients. 9 minus 12 is going to get you minus 3x squared. And then you combine the whole number with the whole number, right? So 6 plus 10 is going to get you plus 16. All right, so this should be your final answer. All right. Like I said, a very common mistake with this one, people forget to distribute this negative to this negative 10, and they just write a negative 10. Right, so minus 10. Right, that is not right. It should be plus 10, right? You're changing the sign of everything in parentheses. All right, good. So now one of the easier examples that you're going to get are ones where you're adding polynomials, right? So here we see a plus. When you're adding polynomials, nothing changes. You can just drop the parentheses and combine like terms, right? You can just jump straight to combining like terms. I see a negative 12x to the 7th and a 22x to the 7th positive, right? These are like terms. I'm just going to combine them like normal, right? So negative 12 plus 22 is going to get you 10x to the 7th. Again, you don't do anything to the exponents on the x, all right? And then the same thing with these x to the 5th terms, right? Negative 19x to the 5th minus x to the 5th. Now, when you don't see a number in front of your variable, you assume it's a 1. Right, so negative 19 minus 1, right, is going to get you negative 20 x to the 5th. All right, and then lastly, 4x squared. I see a 4x squared and a 6x squared. All right, I have 2 terms that have an x squared. I'm just going to combine the coefficients like normal. So plus 10x squared. Right, and this is going to be your final answer. Right, nothing super crazy here, right? Nothing you haven't seen before. All right, so we're just going to keep this going for the next 3 examples. All right, so next example is another subtracting one, right? In this one, we're subtracting the entire second polynomial, right? Again, what I like to do is change the sign immediately. If everything is being subtracted, then every sign changes. I'm just going to rewrite it as minus 4x to the 6 plus 3x to the fourth plus 13. Right? Just rewrite it, changing the signs. And then I'm going to rewrite 6x to the sixth plus 14x to the fourth plus 7. Right? Nothing changes there. Right? We didn't do anything to that one. All right, and now everything that's being subtracted, right, we're just going to combine like terms. Right? We already subtracted, or we already distributed the subtraction to every term. Just combine like terms. 6x to the sixth minus 4x to the sixth is going to be 2x to the sixth. 14x to the fourth plus 3x to the fourth is going to be plus 17x to the fourth. And then plus 7 plus 13 is going to be plus 20. All right, so this should be your final answer. All right, good. All right, so if you're having an easy time so far, perfect, right? Just keep on practicing. You're going to do great on the quiz, right? Otherwise, there's 2 more examples that I'm going to go over, right? Like I said, this one is a plus. If it is plus, if you're adding 2 polynomials, you can just drop the parentheses and combine like terms, right? These are probably some of the easiest problems that you'll get, right? So you see an 18x to the third, 11x to the third, right? They're like terms. We're adding. We don't have to change the sign of anything. Everything stays the same, right? So 18x to the third plus 11x to the third is going to give us 29x to the third, right? And then we just keep this going, right? Rinse and repeat. We do the exact same combining like terms. Negative 16x squared minus 5x squared. Right, negative 16 minus 5 is going to get you negative 21x squared. Right, negative 9x plus 4x. Right, like terms, we do negative 9 plus 4 is going to get you negative 5x. All right, and then this negative 20 is a little bit of a loner. Right, it can't combine with anything, so you just write it on the end. Right, don't do anything to it. If it can't combine with anything, you leave it alone. All right. And then this would be your answer. Again, adding polynomials are probably some of the easiest problems that you're going to get. All right, good. And then one more subtracting. All right, so as always, we're going to take this negative, change the sign of everything, right? This minus is going to change the sign of everything. So then our second set of parentheses, right, this next second polynomial, every sign is going to change. We're going to have a minus 44x squared plus 21, or no, look at that. See, already making a mistake. All right, minus 21x and minus 7, right? All the signs change. And then this first one, this first polynomial, we didn't do anything to that, so we're going to rewrite it, keep it the same. 8x squared minus 9x plus 22. All right. And then like before, combine like terms, right? I see an x squared and an x squared. So I'm going to do 8 minus 44, combine the coefficients. 8 minus 44 is going to get you negative 36x squared. All right. And now negative 9x minus 21x, right? Negative 9 minus 21 is going to get you negative 30x. All right, and then we combine the constants, right? 22 minus 7 is going to get you plus 15. All right, and then so this is your answer. All right, so very straightforward stuff, right? Just the biggest thing when you're subtracting polynomials, make sure you change the sign of everything inside of your polynomials, right? That's probably the most common mistake for these kinds of problems, right? So just stay on top of your signs. Make sure you're changing the signs accordingly and leaving them alone when you're adding. All right. All right, and now, right, maybe the most challenging part, which still isn't super difficult, but the one that might involve a little bit more work is multiplying polynomials. All right, so some of the easier examples that you're going to get are multiplying binomials. Right, so 6 and 7, you can see here, these are binomials. When you're multiplying binomials, you FOIL. whoa, hold on. Is this, okay, yeah. You FOIL, right? So foiling, we're going to do first times the first, t times t is going to get us t squared, right? Outer times the outer, right? Outer times the outer. T times negative 12 is going to get you negative 12t, right? Inner times the inner, so 6 times t is going to get you plus 6t. And then the last times the last is going to get you negative 72. All right, 6 times negative 12 is going to get you negative 72. And then from here you can combine like terms, right? Negative 12 plus 6 are like terms. They both have a t. So we're going to do minus 6t and then leave everything else the same. All right, so your answer should look like this. All right. And then the next one's going to work out very similarly, right? We have two binomials we're going to FOIL. All right, so like before, first times the first, 4a times 2a, we're going to multiply the coefficients. 4 times 2 is 8. A times a is a squared, right? Outer times the outer, 4a times 6 is going to be plus 24a. All right, inner times the inner is going to get you negative 10a, right? Negative 5 times 2a. And then negative 5 times 6 is going to get you negative 30. All right? And then just like before, we're going to combine like terms, right? Our like terms are in the middle, right? 24a minus 10a, right? So 24 minus 10 is going to get you 14a. And then minus 30, all right? And then a squared plus. Right, so once you combine the middle two terms, everything else stays the same. This should be your answer. All right, so let's finish up this page. All right, there's 8 more problems on multiplying polynomials. All right, so let's just try one more foiling problem. All right, so in this example number 8, we have a 3x squared minus 7 times 2x plus 5. All right. Now, here we're just going to FOIL, same as before. All right, so if we do first times the first, whoa, hold on. Okay, wait, hang on. Okay, if we do first times the first, right, 3x squared times 2x is going to give us a 6x to the third power, right? 3 times 2 is going to get us 6, x squared times x. You can think of this like x to the first power and then add the exponents. All right, and then let me draw the little arrows. I know some of you like the arrows. All right, and so outer times outer, we're going to do 3x squared times 5. All right, so 3x squared times 5 is going to give you 15. Right, 3 times 5 is 15, and then x squared. All right, inner times the inner. All right, so negative 7 times 2x. All right, negative 7 times 2 is negative 14. And then times x, you're just going to write it off to the side. And then negative 7 times 5 is going to get us a negative 35. All right, and then here there are no like terms. All right, so this is going to be your final answer. All right, this one was a little bit different because we didn't have those middle two terms that combined. Right, this time we have all different variable exponents and a constant. All right, so we just leave it alone as is. All right, there's nothing else we can do to it. All right, and then the next example, right, is going to be a little bit different from foiling. This time we don't have a binomial times a binomial, so we cannot FOIL. We have a binomial times a trinomial, right? In these kinds of examples, or in these kinds of problems, what I do is I take one term of the binomial and distribute it to each term of our trinomial. And then I do the same thing for the next term, but let's just take it one at a time. So x distributed to every term in the trinomial. X times 4x squared is going to give you 4x to the third power. X times negative 5x is going to give us a negative 5x squared. And then x times positive 8 is going to get us a plus 8x. All right, and then we do the exact same thing for the next term, right? So 5. right? Positive 5, we're going to distribute that to each term of our trinomial. 5 times 4x squared is going to get us a plus 20x squared. 5 times negative 5x is going to get us a negative 25x. And then a 5 times 8 is going to get us a plus 40. All right, and now we can combine like terms. Right, I see a minus 5x squared and a plus 20x squared. All right, so these are like terms. We're going to combine the coefficients. Negative 5 plus 20 is going to give us plus 15x squared. Right, and then I see more like terms, an 8x and a negative 25x. Right, combining these, 8 minus 25 is going to get us negative 17, and x was our variable. And then nothing else can combine with anything else, so I'm just going to rewrite the 4x cubed and the plus 40. All right, so this is your answer. All right, and it's going to work out exactly the same way when we have a trinomial times a trinomial. Right, so when we do number 10, right, I'm going to do it the exact same way. I'm going to take one of our terms of our trinomial, the first one, distribute it to each term of the second trinomial, right? And then repeat it 2 more times for the other 2 terms, right? But again, let's just take it one at a time. So 2x squared times x squared is going to get us 2x to the 4th. 2x squared times 3x, well, 2 times 6, or 2 times 3 is 6. So plus 6, and then x squared times x is an x cubed. And then 2x squared times 2 is a plus 4x squared. All right, and then we just repeat that process for the other 2 terms. All right, so negative 11x, distribute that to each term of our trinomial. All right, so negative 11x times x squared is just going to be negative 11. X times x squared is x cubed. Negative 11x times 3x, well, negative 11 times 3 is negative 33. And then x times x is x squared. And then negative 11x times 2 is going to get us a negative 22x. All right, and so same thing for our last term, right? So I'm going to take this positive 3, distribute it to each term of the second trinomial, right? So this is going to give us plus 3x squared plus 9x and plus 6, right? 3 times 3x and 3 times 2. All right, and then as always, we're going to combine like terms. 2x to the 4th, nothing can combine with that, so I'm just going to rewrite it. 2x to the 4th. All right, I have a 6x cubed and a minus 11x cubed. All right, 6 minus 11, combine the coefficients, is going to be negative 5x cubed. All right, 4x squared minus 33x squared plus 3x squared. Okay, well, negative 33 plus 3 is negative 30. And then negative 30 plus 4 is going to get you negative 26x squared. All right, and then negative 22x plus 9x are like terms, so we do negative 22 plus 9. That's going to get us negative 13x. All right, and then nothing can combine with 6, so I just write a plus 6. All right, and then this is your answer. All right, so this is as hard as it gets for multiplication, is multiplying a trinomial times a trinomial. At least as hard as you're going to see, right, on your quiz. Right, you can make it harder just by putting more terms in it, right? But this is as hard as you'll see, right? Or as hard as we even discussed in class. All right, so if you can do this, you're doing great. All right, otherwise, keep on practicing, right? There's some examples like this in the notes. There might have been one on the homework. I'm not sure. But the same process as always, right? We're distributing each term. All right, good. All right, and then the next one. All right, so this is where we got into our special products section. All right, so special products we use when we can recognize a certain pattern in the polynomials that we're multiplying. In this case, we do have one of those patterns, right? So I have the same term, b and b, another similar term, 10 and 10. One is minus, one is plus. All right, when this happens, you have a special product, right? And if you remember, our special product, right, for a minus b, or a plus b times a minus b, right, this is just going to equal the first term squared minus the second term squared, right? So let's go ahead and do that, right? So b squared, I'm just going to write as b squared minus 10 squared. And then, of course, you're going to want to simplify and evaluate 10 squared, right? So then your final answer, this is just going to be b squared minus 100. All right. And like I said in class, this is one of the most useful special products that you will see, right? So you could have done it the other way just by foiling, right? B times b, you get b squared. B times 10 is plus 10b. Negative 10 times b is negative 10b. And then negative 10 times positive 10 is negative 100. And then notice that the middle two terms cancel out and you end up with the exact same thing, right? But if you could recognize the special product, you could have done it in one step. Just square the first term minus square the second term. All right, but if you're not comfortable with that, FOIL. All right, you'll always get the right answer when you're multiplying a binomial times a binomial when you FOIL. All right, good. And then on that note, we have another special product, right, for number 12, right? So you could do it by foiling, right? But if you can recognize a special product, you don't have to deal with that middle term canceling out, right? Why would you write it if you know it's going to cancel out, right? So just save yourself the writing, right? If you can recognize this, you can do it in one step, right? So this is, in fact, a special product, right? I have a 6x and a 6x, a 5y and a 5y. One is minus, one is plus. This is a special product. All we're going to do is we're going to square the first term, right? And then minus square the second term, right? So 6x squared, that's going to be 36x squared, minus 5y squared is going to be 25y squared. All right. And now again, you could have done it by foiling, right? But this way is much faster and easier, right? So this is one special product that you should remember. All right, nice work. So now we get into more patterns, right? More special products. One thing that I will always emphasize, you cannot, when you see something like this, 2m plus 9 squared, you cannot raise both of these terms to the second power and do 2m squared plus 9 squared. That is absolutely wrong, right? You will not get full credit if you do it this way, right? And it is very tempting, right? It looks like it would work out nicely if you were to just square each term. But you miss out an entire middle term, right? There is another term that this answer does not reflect, right? So you cannot, when you see something like this, raise each term to the second power. That is absolutely incorrect. You will not get full credit. All right, good. Let me go ahead and erase this, right? And let me show you how to actually do it. All right. Okay. So when you see something like this, right, the route that most kids like to do is they just like to FOIL it. So they just do 2m plus 9 times 2m plus 9, right? This is how you would actually evaluate it, right? So something like this, foiling, you would just do 2m times 2m, which is going to give you 4m squared, right? 2m times 9 is going to get you plus 18m, right? 9 times 2m is going to get you plus 18m, right? And then 9 times 9 is 81. All right, it's kind of light, but I'm going to rewrite it in a second. All right, and then notice that when you combine like terms, the middle two terms combine. All right, and then you get 4m squared plus 36m plus 81. All right, the middle two terms combine, 18 plus 18 is 36. All right, so this should be your answer. Now you could have also recognized that this is a special product, right, that takes this form, right? If you see something like two terms being added squared, this is always going to be the first term squared plus 2 times the first and the second term plus b squared, right? So this is the second term squared. All we have to do here, if you use the special product, label them, right? The first term, 2m, I'm going to say that this is a. 9, I'm going to say is b. Right? So then you can just plug this in to the special product. Right? So then I have, this is going to be equal to 2m squared, right, plus 2 times a, which is 2m, times b, which is 9, so times 9, and then plus b squared, so plus 9 squared. Right? And then you get the same answer, right? 2m squared is going to give you 4m squared. And then 2 times 2m is 4m times 9 is going to get you plus 36m. And then 9 squared is 81. Notice that you get the exact same answer. I encourage you to try it both ways just to see what you like more. Right? Some kids were telling me in class they like the special products because instead of like it's easy to make mistakes with foiling if you're prone to those mistakes and you find it easier to just memorize a formula and plug in the terms as you recognize them, then go ahead and do that. That's going to make the work easier in the long run, right? But if you try it a couple times and you're like, I don't like memorizing all of this and I find it easier to foil, then just foil it. You're going to get the exact same answer, right? Either way you do it is correct. All right, good. On that note, the second one is going to work very similarly, right? This time I have a difference, so x minus 8, right? The special product is going to look very similar. So a minus b squared, right? If you're doing this by special products, it's going to be a squared minus 2ab plus b squared. The only difference between this one and the last example was the minus, right? So this one is now minus, right? Here it was a plus, right? Okay, good. Whoa, hang on. Okay, so we can label it. Whoa, that might have just messed it up. Wait, hang on. Sorry, I lost my pen. Okay, where did it? Okay. Sorry about that. Okay. If you're using the special product, you can just label it, right? So x, we can say that this is our a term, so our first term. 8, we can say, is our b term, right? Our second term. And if we remember our special product, we know that this is just going to be equal to, right? Our a term is x squared, right? And then minus 2 times a, which is our x, and then times b, which is our 8, and then plus 8 squared. All right, so then all we have to do is evaluate this. X squared is just x squared. Negative 2 times x times 8 is going to give you negative 16x, and then 8 squared is 64. See how that was much less writing than foiling it out, all right? And I'm even going to show you how you would do it foiling it out, right? So to foil this, you can do x minus 8 times x minus 8. Write it twice. All right, and then we can do x times x, all right, outer times outer. First times first is x squared. X times negative 8. This one is outer times outer, so negative 8x. Right? Inner times inner, negative 8 times x is negative 8x again. And then negative 8 times negative 8 is positive 64. And then when we combine like terms in the middle, right, this is another common mistake that even if people were to FOIL it out like this, they still think the middle two terms cancel out. They do not, right? Negative 8 minus 8 is not going to cancel out and make 0. This is going to give you negative 16x. Negative 8 minus 8, right? Same sign, you just add and keep the sign, right? If we remember that from however long ago, Algebra 1, middle school, whatever. All right, and then you get the same exact expression, right, as we did when we used the special products. Now again, I'll emphasize it is a choice for you, right? You don't have to do the special product if you just like to FOIL, right? But one thing I will always say, you cannot see the 2 over a set of parentheses and raise each of these terms to the second power and say it's going to be 8 squared, or no, x squared minus 8 squared. Again, that is absolutely wrong. You will get the question wrong. You will not get full credit if you do it that way. Do not get into the habit of doing that. I know it is very tempting. It looks like it's going to make it super easy, but it is not, right? You need to write it out both ways. And that also doesn't mean that the question is super hard, right? You guys know how to FOIL. It's not super difficult, right? But it doesn't work out as nicely as if you were to just square both terms, right? So do not get into that habit. Do not make that mistake. All right, good. And now one more example. All right, number 15. All right, this time it's cubed, right? I have an x plus 3 cubed. Once again, do not raise each of these to the third power, right? I think you guys get the point, but I'm going to keep saying it. Do not raise each of these terms to the third power and say x cubed plus 3 cubed. It is a very common mistake, and I guarantee I'll see it at least once, right? It is a very common mistake. Do not make that mistake, right? Do not do this on the quiz, right? It is not correct. You have to actually either write it out 3 times and multiply, which I'm about to show you, or do the special products, which I'm also about to show you, right? But I'm going to start with the way that most kids tend to like, and it is just by multiplying it out 3 times, right? So what does it mean to cube something? It just means to multiply it by itself 3 times. So I'm going to do x plus 3 times x plus 3 times x plus 3. All right, now I don't want you to see this and get too caught up in multiplying all of it all at once, right? You're gonna be prone to errors, right, if you do it that way, right? So let's just stick with what we know, right? We already know how to multiply a binomial times a binomial. So what I'm gonna do, I'm gonna multiply, FOIL, right, the first 2 terms, x plus 3 times x plus 3, and then I'll deal with this last x plus 3 at the end. All right, so let's start by FOILing x plus 3 times x plus 3. All right, as always, first times the first, x times x is x squared. Outer times outer, x times 3 is going to be 3x. Inner times inner, 3x. All right, we get another 3x. And then 3 times 3, last times last is plus 9. Combining like terms, I have 3x plus the 3x is going to be a plus 6x. All right. And then we just drop down the plus 9, and then the x squared plus. And then I'm going to write these in parentheses, and then we still have to multiply this binomial, right? I'm going to bring it down because we're still going to multiply it. All right? And then from here, we've done maybe a couple examples like these, right? If you have a trinomial times a binomial, you're going to distribute each term into the second polynomial, right? So our first polynomial here is this trinomial, x squared plus 6x plus 9. I'm going to go ahead and distribute the x squared to each term in our binomial. So x squared times x plus 3 is going to get you x squared, or no, x to the third power plus 3x squared, right? X squared times x, right? You can think of it like an x to the first. And then they have the same base, so you're going to do 2 plus 1, which is 3, right? And then 3 times x squared, right? You can't multiply a variable and a whole number, right? So you just write it like this. And then we repeat that process for the other 2 terms, right? 6x we're going to distribute to x plus 3. 6x times x is going to be a plus 6x squared, right? We have 2 x's. And 6x times 3 is going to be plus 18x. 6 times 3 is 18, and then just throw the x on it. All right, and then 9, positive 9, distribute that to the x plus 3 is going to be plus 9x, and then plus 27. All right. And now, as always, we're going to combine like terms, right? So 3x squared plus 6x squared, they both have an x squared. We add the coefficients. 3 plus 6 is 9. Keep the x squared. All right, 18x and 9x. Also add the coefficients because they both have an x. It's going to be plus 27x. Right, and then you can just bring down that 27, so plus 27, and then bring down that x cubed. So x cubed plus. All right. Okay, good. Now the other way that you can do it is by special products. All right, so I'm going to write special products. Our special product here, right, and this is in your notes. If I have a plus b cubed, this is the same as a cubed plus 3a squared b plus 3ab squared plus b cubed. All right. It's always going to look like something like this. And again, you might be looking at this and you're like, that is absolutely crazy. I'm not going to memorize that. Or you could say, okay, well, if I know what the answer is supposed to look like, I'd rather just memorize it and then plug things in, right? It really depends on what works for you. And I'm going to keep saying it, right? There's really, either way you do it, you're going to get the correct answer, assuming you follow each step correctly, right? So try them both out and see what works for you, right? If you want to memorize this, go ahead. And if you want to keep memorizing it, or no, if you want to memorize it, I'll keep working on it, right? And I'll show you this way, right? In this expression, I have an x plus 3 cubed, right? We can say a is our x, and then b is our 3. Right? And because this is a special product, we know how our answer is supposed to look. I'm just going to plug in our a and b into this formula here. It's going to give us an x cubed, right? So plus a 3. Our a is an x, right? So x, oh wait, hang on. X squared, right, times 3, right? B is our 3. And then plus 3. And then our a term is our x. And then b squared, we're going to write 3 squared. And then plus b cubed is going to be plus 3 to the 3rd power. Right? And then you just multiply all of this, right? So this is just going to be x cubed. 3 times x squared times 3. Well, 3 times 3 is 9. And then you just write the x squared with it. So plus 9x squared. 3 times 3 squared. Well, 3 squared is 9, and 9 times 3 is 27. And it has an x, right? So plus 27x, right? And then 3 times 3 times 3 is going to be 27. Notice that we get the exact same answer, right? So it really just depends, right? Do it either way that you feel comfortable. I've seen kids do it both ways, and I've seen good stuff both ways, right? So whatever works for you. Some common mistakes that I see in this section are just minor computational errors and like really silly mistakes. I think for the most part, all my classes can do this pretty well. Just I've seen little mistakes, right? So just be mindful of that because that could cost you some points, right? And when I say little mistakes, I mean maybe you write a 27x squared, right? Maybe you just throw in a squared where there isn't supposed to be one. Or maybe you don't write a square when there should be one, right? So little mistakes, and other mistakes are just like computational, right? Maybe you forget how to subtract negative integers, right? Combining a negative integer plus a positive integer, right? Little minor mistakes, right? But these should hopefully give you enough practice with that so that you can kind of iron out those mistakes. All right, but this review is posted on Canvas, right, with worked out solutions. I even write little notes, right, so that you guys can follow along. And then there's also this video, of course. But yeah, any questions, feel free to reach out anytime. All right, good luck.